another point that we are supposed to know for the sake of pointing, vector pointing theorem and all, and we should know it properly, is energy density. Now, we are sure of one point. Check it carefully. We saw the energy stored in the capacitor, derived the expression for it, but we saw the energy stored in the capacitor as the potential energy stored in the deformed atoms present in the dielectric region. Deformed atoms in the dielectric region. This deformation increases with increase in electric field intensity. You agree that? Because they are pulled apart. More deformation talks about more amount of energy getting stored in the atom. So one point is now clear, that energy is stored in the deformed atoms where the deforming agent is electric field intensity, which is the force. So wherever electric field is there in the dielectric region, it need not be the capacitor only. Wherever electric field intensity is there, charge is stored. Energy density, when we talk about, it is the energy stored per unit volume of the dielectric. When it is in the electric field, right? Of intensity E in general at any point. Stored per unit volume at any point, I'll say. And I understand the implications of this definition, right? Energy stored per unit volume in complete volume, E will not be fixed. At each and every point, different E will be there in general. So per unit volume is delta E by delta V. Delta E is the energy stored. So there is basically, there are complicated derivations for this, ultimately come down to the same. I will go through the simple procedure. I know that total energy stored, if it is true in one case, it should be true everywhere, because of which I am considering this example only. This is the capacitor of capacitance C, charged to V volts. This is plate area A, distance between them is D. Total energy stored, please look at it. In the dielectric of volume V, sorry, AD, A into D, correct? Total energy stored in the dielectric of volume AD derived to be is what? Is equal to half epsilon, half C squared, right? Half C is what? Epsilon A by D. V is what? Magnitude of E into D. CV squared. E is magnitude of E. That's enough for me. Whether E is there to the left or right, the deformation is fixed. Do you agree that this is C? This is the magnitude of V. Energy is, I'm basically looking at energy stored, energy scalar. Ultimately, what is this? Energy stored is equal to, in the volume AD is equal to what? Half epsilon A D E squared. Total energy stored. EN I will call ENT. What is energy stored per unit volume? By AD. Energy density. Total energy stored divided by the volume of the dielectric, which is AD, is half epsilon E squared. So many joule per meter cubed in a system of units. So at any point where the electric field intensity, a magnitude of the electric field intensity is capital E, energy stored per unit volume of the dielectric of permittivity epsilon is half epsilon E squared. Just to strengthen this point, let us consider the cylindrical capacitor, or spherical also, but I will consider cylindrical because it is practical for me. See the beauty of it actually. Half epsilon E squared, energy density in the field, wherever E is there. We saw that with a charge Q on the conductors, right? Electric field intensity is what? E at any R as a function of rho is equal to what? Phi and Z, it is independent. E as a function of rho is Q by 2 pi epsilon rho L. E rho. Energy stored per unit volume is half epsilon Q square by 2 pi epsilon whole squared rho squared L squared. Is the energy density at any point? Please check it. And the total energy stored between the conductors is what? A to B. Differential volume in between these two is what? Rho from A to B. Hey, what is differential volume? Rho d rho d phi dz. A to B rho. Phi from 0 to 2 pi. Z from 0 to L. If you simplify this, rho square get cancelled out. D rho by rho is ln of rho. Half of ln of B by A. Then integral d phi is 2 pi. Integral dz is L. The constant is epsilon Q squared by 2 pi epsilon whole squared L squared. Check it. What will happen to this? 2 pi epsilon L. This 2 pi epsilon L whole squared will go. I can always write it as half of Q squared by 2 pi epsilon L by ln of B by A. For the cylindrical capacitor of length L and radii A and B, what is this? This is C, which is equal to Q squared by 2C. I want to just show this. I use the concept of energy density. If I know the magnitude of electric field intensity at any point, I know the amount of energy stored per unit volume of the dielectric there. In the volume between the cylinders, I determine the total energy stored. And I got some expression as the total energy stored, which can be put in the form of Q squared by 2C, which is the energy stored in the capacitor of capacitance C, when there is a charge of Q coulombs on each of the conductors. Please check it. So, to be remembered is what? At any point where the electric field intensity is E bar, energy stored per unit volume of the dielectric at that particular point, at any point, is what? Half epsilon mod E bar whole squared, which is actually E bar dot E bar. And there are several ways of complicated ways of coming to the same solution, but I prefer to take this example, define it in one case, apply it in the other case, and prove that it is correct. I took the parallel plate capacitor, defined energy stored, and then applied to the cylindrical capacitor. I got the energy stored as half Q squared by C. See? So it's correct. And we can use that whenever it is required for us.